Said that the wars of the 21st century may well be fought over water. The Earth's population has more than doubled over the last 50 years, and the demand for fresh water to drink and to grow food has surged along with it. But sources of water, like rainfall, rivers, streams, reservoirs, certainly haven't doubled. So where is all that extra water coming from? More and more it's being pumped out of the ground. Water experts say groundwater is like a savings account, something you draw on in times of need. But savings accounts need to be replenished, and there is new evidence that so much water is being taken out, much of the world is in danger of a groundwater overdraft.
The story.
California is entering its fourth year of a record-breaking drought. Last year was the driest since the state started keeping records more than 100 years ago. And yet, pay a visit to California's Central Valley, and out of that parched land, you'll see acre upon acre of corn, almond trees, pomegranates, tomatoes, grapes, and what makes them all possible, water. Where do you get water in a drought? You take it out of the savings account, groundwater.
We're talking about surface water, we're talking about lakes and rivers. Okay, when we're talking about groundwater, we're really talking about water below the water table.
Jay Famiglietti, an earth sciences professor at the University of California, Irvine, is a leading expert on groundwater.
It's like a sponge. It's like an underground sponge.
He's talking about the aquifers where groundwater is stored, layers of soil and rock, as he showed us in this simple graphic, that are saturated with water and can be drilled into, like the 3 wells shown here. You can actually pump it out of the crevices?
Imagine like trying to put a straw into a sponge. You could actually suck water out of a sponge. It's a very similar process.
Sucking the water out of those aquifers is big business these days in the Central Valley. Well driller Steve Arthur is a very busy man.
All the farmers, they don't have no surface water. They've got to keep these crops alive. The only way to do that is to drill wells, pump the water from the ground.
So it's either drill or go out of business?
Yes.
So there's something of a groundwater rush going on here. Arthur's 7 rigs are in constant use, and his waiting list is well over a year. And because some wells here are running dry, he's having to drill twice as deep as he did just a year or 2 ago. This well will cost the farmer $250,000 and go down 1,200 feet, about the height of the Empire State Building.
Are you and are the farmers worried that by going that deep you are depleting the groundwater?
Well, yes, we are depleting it, but on the other hand, what choice do you have? This is the most fertile valley in the world. You can grow anything you want here. If we don't have water to grow something, it's going to be a desert.
He said many farmers think the problem is cyclical and that once the drought ends, things will be okay. Now, when they take water out and it rains,
Yes.
doesn't the water go back down there?
These aquifers near the surface, they can sometimes be replenished very quickly. If we're talking about a deeper aquifer, that could take tens or hundreds of years to recharge.
Figuring out how much is being depleted from those aquifers deep underground isn't easy. Hydrologist Claudia Font took us to what looked like someone's backyard shed, where she and her colleagues at the U.S. Geological Survey monitor groundwater levels in the Central Valley the way they always have, by dropping a sensor down a monitoring well. So this is a well.
This is a well. We have a tape here that has a sensor on the end.
Oh, let me see. The Geological Survey has 20,000 wells like this across the country. It's a tape measure.
It's a tape measure.
How will you know when it's hit water?
It's going to beep.
By comparing measurements from different wells over time, they get the best picture they can of where groundwater levels stand. She unspooled and unspooled until finally... Oh! It startled me, as did the result, a 5-foot drop in just 1 month.
Right now, we're reaching water levels that are at historic lows.
Historic lows.
Right. At this site, water levels have dropped about 200 feet in the last few years.
Gathering data from holes in the ground like this has been the only way to get a handle on groundwater depletion. That is, until 2002 and the launch of an experimental NASA satellite called GRACE.
What does GRACE stand for?
So GRACE stands for Gravity Recovery and Climate Experiment.
Mike Watkins is head of the science division at NASA's Jet Propulsion Laboratory in Pasadena. He was the mission manager for the latest Mars rover mission, and he is the project scientist for GRACE.
So the way GRACE works is it's two satellites.
Two.
They're actually measuring each other's orbit very, very accurately.
What affects that orbit is gravity.
As the first one comes up on some extra mass, an area of higher gravity, it gets pulled away from the second spacecraft.
And that's where water comes in. Since water has mass, it affects the pull of gravity. So after the first GRACE satellite approaches an area that's had lots of heavy rain, for example, and is pulled ahead, the second one gets there, feels the pull, and catches up. The instruments are constantly measuring the distance between the two.
Their changes in separation, their changes in their orbit, are a little different this month than last month because water moved around and it changed the gravity field just enough.
So GRACE can tell whether an area has gained water weight or lost it.
So GRACE is like a big scale in the sky.
Absolutely.
GRACE can also tell how much water an area has gained or lost. Scientists can then subtract out the amount of rain and snowfall, and what's left are the changes in groundwater.
It's kind of brilliant to think that a satellite in the sky is measuring groundwater.
It is fantastic.
I thought it was complete nonsense. There's no way we can see groundwater from space.
Jay Famulietti started out a skeptic, but that was before he began analyzing the data GRACE sent back. The first place he looked was India. He showed us a time-lapse animation of the changes GRACE detected there over the last 12 years. Note the dates on the lower right. The redder it gets, the greater the loss of water.
Oh, look at that.
He calculated that more than half the loss was due to groundwater depletion.
And this is a huge agricultural region.
Have they been doing the same kind of pumping that we're seeing in California?
Yes.
It got so dark red.
Yeah, that's bad.
His India findings were published in the journal Nature. But as he showed us, India wasn't the only red spot on the GRACE map.
So this is right outside Beijing, Bangladesh, and then across southern Asia.
He noticed a pattern.
They are almost exclusively located over the major aquifers of the world, and those are also our big food-producing regions. So we're talking about groundwater depletion in the aquifers that supply irrigation water to grow the world's food.
If that isn't worrisome enough, some of those aquifer systems are in volatile regions. For instance, this one that is shared by Syria, Iraq, Iran, and Turkey.
Turkey's built a bunch of dams, stored a bunch of water upstream. That forces the downstream neighbors to use more groundwater, and their groundwater is being depleted. We're seeing this water loss spread literally across Iran, Iraq, and into Syria.
It's progressive.
Famulietti, who's now moved to the Jet Propulsion Lab to work on GRACE, has started traveling around the world trying to alert governments and academics to the problem, and he isn't the only one who's worried. A 2012 report from the Director of National Intelligence warned that within 10 years, many countries important to the United States will experience water problems that will risk instability and state failure, and cited the possible use of water as a weapon or to further terrorist objectives.
Water is the new oil.
It's true. It's headed in that direction.
And what about our own food-producing regions, like California's Central Valley, which produces 25% of the nation's food? What is GRACE telling us there?
2008?
Right. And now things are going to start to get very red.
2010?
GRACE is confirming what the Geological Survey well measures have shown, but giving a broader and more frightening picture, since it shows that the rainy years are not making up for the losses.
14. Dark red. That's alarming.
It should be.
So much groundwater has been pumped out here that the Geological Survey says it's causing another problem. Parts of the valley are literally sinking. It's called subsidence.
So the ground basically collapses or compresses down, and the land sinks. And
The
this-
land is sinking down.
She said at this spot, the ground is dropping several inches a year.
And north of here, it's more like a foot per year.
That sounds like a lot. A foot a year.
It's some of the fastest rates we have ever seen in the valley and in the world.
She says it's caused damage to infrastructure, buckles in canals, and sinking bridges. Here, the land has sunk 6 feet. It used to be level with the top of this concrete slab.
And this is because of the pumping of the groundwater.
Yes.
Is there any limit on a farmer as to how much he can actually take out of this groundwater?
Not right now in the state of California.
None.
As long as you put it to a beneficial use, you can take as much as you want.
But what's beneficial to you may not be beneficial to your neighbor.
When you dig a well like this, are you taking water from the next farm?
I would say, yeah, we're taking water from everybody.
Or was that neighbor going to be unhappy?
No, everybody knows that there's a water problem. Everybody knows you got to drill deeper, deeper. It's funny you say that because we're actually going to drill a well for that farmer next door also.
Making things worse, farmers have actually been planting what are known as thirsty crops. We saw orchard after orchard of almond trees. Almonds draw big profits, but they need water all year long, and farmers can never let fields go fallow or the trees will die. But with all the water depletion here, we did find one place that is pumping water back into its aquifer.
Look, it really looks ickier up close.
We took a ride with Mike Marcus, general manager of the Orange County Water District, and a program some call Toilet to Tap. They take 96 million gallons a day of treated wastewater from a county sanitation plant, and yes, that includes sewage, and in effect recycle it. He says in 45 minutes, this sewage water will be drinkable.
You'll love it.
You think I'm going to drink that water?
Yes, you will.
They put the wastewater through an elaborate 3-step process. Suck it through microscopic filters, force it through membranes, blast it with UV light. By the end, Marcus insists, it's purer than the water we drink. But it doesn't go straight to the tap. They send it to this basin and then use it to replenish the groundwater.
It's amazing. Because of recycling of sewage water, they've been able to arrest that decline in the groundwater.
All right, I'm going to do it.
All that was left was to try it. To tell the truth, it wasn't bad.
I can't believe how brave I am. 45 minutes ago, this was sewer water.
And now it's drinkable.
He says it's a great model for big cities around the country, but it's not the answer for areas like the Central Valley, which is sparsely populated and therefore doesn't produce enough waste. So at least for now, it's continuing withdrawals from that savings account.
Will there be a time when there is zero water in the aquifer for people in California?
Unless we take action, yes.
California has just taken action, enacted a law that for the first time takes steps toward regulating groundwater, but it could take 25 years to fully implement.